Today I am here to give you some information about construction of a ceiling fan. The starting winding is inserted first in the ceiling fan and is more resistive than the running winding in order to preserve the phase difference between the two windings of magnetic flux. A capacitor is connected in series with the start winding to insert a phase shift, but once the motor is up to speed it becomes an auxiliary winding. You can see in the figure of a ceiling fan. The running winding is also known as main winding is wound on teeth while the auxiliary winding is wound on slots. The running winding is made with bigger wire which increases its inductive reactance while decreasing resistance compared to the start winding. Starting winding and capacitor. You can also see in the picture. The starting winding is connected to a capacitor. When the fan is switched on, electrical current flows to the motor. The capacitor creates a phase shift between the currents in a starting and running winding. This phase shift creates a rotating magnetic field which starts the motor. Phase wiring. The phase wiring in a ceiling fan is responsible for the creating a phase difference between currents in the starting and running windings. This phase difference is crucial for creating a rotating magnetic field that can start and maintain the rotation of the motor. In this way, both the starting and running winding are connected in parallel across the single phase AC supply voltage. When current flows through these winding inductors, it produces a pulsating magnetic field instead of a rotating magnetic field, which is needed for torque and rotation.
Working of a ceiling fan. Starting winding and capacitor. When a fan is switched on, electrical current flows to the motor. The starting winding is connected to a capacitor, which creates a phase shift between the currents in the starting and running windings. This phase shift creates a rotating magnetic field which starts the motor. Rotation and running winding. The rotating magnetic field causes the rotor to start turning. The rotor is connected to the fan blades, so when it turns, the blades turn as well. Once the motor reaches a certain speed, a centrifugal switch disconnects the starting winding from the circuit. The running winding now maintains the rotation of the motor. Phase wiring. The phase wiring in a ceiling fan is responsible for creating a phase difference between the currents in the starting and running windings. This phase difference is crucial for creating a rotating magnetic field that can start and maintain the rotation of the motor. Air circulation. As the blades of the fan they push air downwards, creating a breeze that helps to cool the room. The entire process is responsible for the circulation of air throughout the room. By connecting the capacitor with starting and running along with the phase with running and starting with neutral, fan will rotate clockwise. But by connecting the phase with starting and neutral with running, fan will rotate anticlockwise. Thank you.